Good morning to everyone. In the last session, we focused on how to write a multi-threaded program in Java by extending the thread class. In that, what is the step procedure we have followed? First, we need to extend the class by by defining the user-defined class. The class should extend the built-in class called the thread class. Then we need to define the run method inside the extended class to support the multi-threaded activity. After that, what we have to do means we need to define the object of the implemented class, and then we need to call the start method so that the run method is going to be called. We can create the several child threads if possible. If not, we can create a thread object. Before that, we need to create the user-defined object. The user-defined object should be passed as a parameter to the thread class constructor, so that we can call the thread class object, and using the thread class object, the start method is going to be called. This is the second possible way using the thread class extension. During the multi-threading execution, one main thread is created. Main thread may create several child threads. How many objects we are creating? Those are equivalent to the child threads. Main thread plus child thread all are working concurrently, executing concurrently, so that the context switch shares the processor, whichever the thread is currently idle. That stage, the context switch transfers the control to execute some other child thread or some other main thread. There are two important properties of the context switch. One is a thread can voluntarily relinquish its control. Second one, when there is a higher priority thread comes to work, actually the higher priority thread is preempted by the lower priority thread. That means higher priority thread can take more precedence or to execute. That stage, lower priority thread will release its control so that the priority is given to execute the higher priority thread. Now have a look into this program. This is the second possible way to create a multi-threaded program. This is done with the help of implementing the runnable interface. What is runnable interface? Where is it defined? Runnable interface is a part of which package?
Java.lang.
The runnable interface provides a method called run method, void run method. Whenever a class implements an interface, the class must implement, that means the class must redefine all methods in that interface. We have already checked that the runnable interface defines a method called void run. Now this is the user defined class. The class implements a runnable interface. So we must redefine the corresponding run method. In its redefinition, the method should be preceded by a keyword, a public void. We can see there are no such significant differences between the extending the thread class and implementing the runnable interface, because the common thing is runnable interface provides a method called run method. The run method is also defined in, right, which one? Thread class. In what way run method is related to the thread class? In what way run method is related to the thread class? What is a thread class? A thread is a class which is defined in Java's language package. How a thread class is defined? Thread class is defined by extending which one? Runnable interface. So since the class, one minute, let me show it again. Java online help. go to this base module java.base, in which find a package java.lang, explore the classes in it. One of the important thread class is thread. How a thread class is defined? Public class thread, right? Not implement, not inheritance, right? It's just implementation because runnable is the interface. Class thread extends object because object is a superclass, right? This performs the inheritance with respect to the object. Then implements runnable. Since the class thread as a built-in class implements the runnable interface, now the class must implement all the properties of a runnable interface. That means all the methods of runnable interface. So the thread class currently has a method called a run method. Now the user-defined class, which has been extending a thread class, means that we are performing method overriding concept so that the void run method is redefined in the extended class. The same way here, the instead of the built-in class here a thread, we are defining our own class called say a new thread. That is a user-defined class. The user-defined class implements the runnable interface. Now the implemented class must redefine the run method, public void run. So similar to extending the thread class, here the class name implements the runnable interface. Then here, right, what are you going to do means here the procedure is different. You need to create the object of the class that implements a runnable interface. That object should be passed as a parameter to thread class constructor. Thread t is equal to new thread of, then you need to pass that object. Using that object, you can call the start method. That is the procedure when the user defined class implements the runnable interface. In this example, the new thread, this is a user defined class. I think the code has been taken from your complete reference book. Initially, right, if you see, right, it seems somewhat a difficult one. Don't confuse here. I explain. Class new thread implements runnable. New thread, this is the constructor. From the constructor itself, the author had tried to call the run method. That is the only thing. If possible, the constructor is defined here. You can create the objects inside the main method. I show it in the next example. New thread here. This is the constructor. Thread t. T is one instance variable here. T is equal to new thread of this. What is this? This refers the invoking object. So when you invoking object, when you call the constructor of the new thread from the main method, the invoking object is received in the variable this. This comma some string message, the demo thread. System.out.println, the value of child thread t is printed. Now t is used to invoke the start method. So understand clearly, this means the object of new thread is passed as a parameter to thread class constructor. Then the object of thread class invokes the start method, that is invokes the run method. Here the code has been placed inside the constructor itself. So simply t dot start means the run method is invoked here. Inside the run method, right, if we need, we can define the exception handling framework. Printing the value of I over the range of 1000. I greater than 0, I minus minus, the value of I is printed. While executing the run method, the child thread is set to sleep for 5000 milliseconds. That stage, control may go to execute the main method. In main method, because I think no other child thread is created in this example, only one child thread is created. Then the control comes back to execute the main method. Unnecessarily, main thread is waiting for 5000 milliseconds. So after 500 milliseconds elapsing, since the main thread is waiting for 5000 milliseconds, so it seems that 10 times the not 10 times, right? 10 into 5, 5,000, 10 into 500, 5,000. Because one time, right, this is executing. Then 500 milliseconds, this is the child thread is waiting. That stage, main thread is also waiting. Then control comes back after 500 milliseconds. Then control comes again to execute the run method of child thread. Then another 500 milliseconds waiting time for the child thread. Main thread is waiting. So it seems that right some a fixed number of times the child thread is going to execute. Of course, okay, at 10 into 500, right, 5,000. So it seems that almost right at 10 times the child thread gets executed after every sleep of 500 milliseconds. So finally, right, we can conclude that a main thread is going to be executing because when the main thread is waiting for 5,000 milliseconds for each value of 5, that stage what will happen means control goes to execute the execution of the child. Only thing is the how the class has been defined, right? The class has been defined by implementing the runnable interface. Similar to the second version of a thread class extension, here the user-defined class object is passed as a parameter to thread class constructor. Using the thread class object, we have invoked the run method using thread class object dot start method. Let us check this activity. Java C multithreading 7.java. Java multithreading 7. Could not find or load main class. Multithreading 7. Java C multithreading 7.java. Java multithreading 7. Take the class name multithreading 7 file save as multithreading 7.java. Yes. What is error message? Class multithreading 7 new thread. New class name is same new thread. File save as a colon within this folder multithreading all files 7.java. Save. Save. Threads are available. Check if anything is missing in this class new thread implements example. I think no compilation error. Public static void main string arguments. New thread. I think there is a problem in path. Okay, the path has been unexpectedly set to that folder C colon slash PSC 208 CSC 208 Java packages. Last yesterday I tried to get some packages coding. One of the asked for the queries. So that stage I set the path to that folder. So unexpectedly the path has been set to the package folder. So with respect to our code here, what happens? The child thread is going to print the value of 5. After printing each value of 5, it is going to sleep for 5000 milliseconds. That stage, control goes to execute the main thread. While the main thread is waiting for 5000 milliseconds, a control comes again to execute the child thread after the elapse of 500 milliseconds. So during the runtime, you can see this is the elapsing time for zero point 0.5 second actually, that is 500 milliseconds. Threads are executing, child thread is executing. After the complete execution of the child thread, then you can see main thread may finish its execution. At times, right, because of that elapsing time, control may also come to execute the main thread. Here you can find, right, the value of main thread is decrementing, right, the value of I is decrementing to 1. Then at the same time, right, you can see the message in main thread 1000 triple nine or something. It takes time to complete the execution. So let me close it and let us move on to the next example.
Sarvari, can you tell where the child thread is being called? I mean, the method is called.
Child thread is called. Child thread is called here from the main thread itself because we are invoking the just the constructor new thread. So in this stage, what will happen is constructor is going to be called here. So while calling the constructor, here itself we are writing t is equal to new thread of discover demo thread, and the thread object t has been created here. Using t, we are calling t dot start. Constructor itself invokes the run method. So here t is treated as a child thread. See the next example. The same code that we have seen earlier. The main method creates the child thread. That means here the thread class constructor is removed. Main method creates the child thread, and from the main itself we are invoking the run method. The same code. Only thing is here the implemented the runnable interface implemented class object. Say nt is created. A new thread nt is equal to a new thread. Then thread t is equal to new thread. Thread class object is created in which the thread class constructor receives the parameter of a new thread object. Int is passed as an object to thread class constructor. Then from the main method itself, we are calling the child thread. T dot start. Child thread is called here. Then nt dot start, right? This will not work. What is nt? Nt is the object of this one, a new thread class. This will not call the corresponding run method. That's what when you implement the runnable interface, you need to define the object of the runnable interface class. That object should be passed as a parameter to the thread class constructor. Then using the thread class object, you need to call the corresponding start method t dot start. This is the flow of execution. This example is similar to the previous example. Only one thing, the constructor is removed here, and the calling of run method has been completely placed inside the main method. Having any queries in this?
Sir,
Yeah, tell me.
sir, can you once again explain why is the nt dot start is not working, sir?
Nt dot start is not working because here the run method is actually defined inside the runnable interface, right? Now, I think have you gone through the interfaces concept? Here, the runnable interface provides the corresponding run method. Using the object of this new thread class, this interface method, right, will not be accessible because here you need to create one instance variable, a reference variable of this runnable interface one. That runnable interface reference variable should be pointing to the object of which one, the new thread class. So when the runnable interface reference variable is pointing the object of this one, a new thread class, then using that runnable interface reference variable, we can call the corresponding run method. In this case, we need to pass the object empty as a parameter to thread class constructor. Then the thread class can have the rights to call the corresponding start method. Since the thread class which implements the runnable interface, so using the thread class object, I can call the corresponding start method. In this example, let us create a multiple threads for a single class. Class new thread implements runnable. Constructor is defined here. We need to check, right, which child thread is currently entering into the run method. To check that, here we defined one string instance variable, say name, string name. The constructor is defined, new thread string is the value of s is being copied into the string instance variable name. Name is equal to x. Name is equal to s. CRC++ we need to use the strcpy function. Here one string instance can be directly assigned to another object of the string one. Then thread t is equal to new thread of this command name. If you want to set the name, right, you can use this one, a t dot set name to set the name of the child thread. Then system.out.println child thread t. Then you can call the corresponding run method. Here itself we can use t dot start. Then run method is defined inside the main method. For the new thread class, we have created three objects, say n1, n2, n3. To illustrate which child object is currently working in the run method, because here in the run method we do want to print the value of name. In case the run is being called by object n1 means n1's instance variable name initializes a value 1. Then the value name is printed means we can conclude that currently this run or this println statement is executed by this child object, say n1, or this is n2, this is n3. So three child objects n1, n2, n3 are created. Then here thread class objects t1, t2, t3 are created. t1 is equal to new thread of this object n1 is passed. Here t2 is equal to new thread of n2, new thread of n3. Then we are trying to call T1 dot start, T2 dot start, and T3 dot start. So three child threads are competing each other to complete their execution. So from the main itself, we are calling the start method. The main thread is waiting for 500 milliseconds for each value of 5. That stage, a control can be transferred to execute the child thread. Here unnecessarily we set the child thread sleeping timers at 2000 milliseconds. So that stage rate we can expect main thread right may complete its execution before the complete execution of the child. Multi-threading 10 only. Let us check the code. First, right, see the flow of execution in main method. We have commented out these lines t dot start. So thread class object t1, t2, t3 are created. T1 dot start, T2 dot start, and T3 dot start. Three child objects are created. That stage, uh, thread T1 is equal to new thread of n1 comma 1. Before that, the constructors are called new thread of 1, new thread of 2, new thread of 3. That stage here, we have printed the value of child thread 3. So it seems that the three child threads are created. Child thread 1, then child thread 2, child thread 3. 5 indicating that the corresponding normal priority. Then child thread 1, 5, 2, 5, which indicating that child thread here 1, 5, 2, 5, which indicates that the first child thread is printed the value of 5. That is the mean child thread 1, 5. Child thread 2, 5. Second child thread printed the value of is 5. Then main thread prints the value of is 5. Then main thread is waiting for 500 milliseconds. Then it may transfer the control to execute the child thread. Then child thread, say 3, 5 is printing. Main thread 2, main thread is finishing its execution because we set a higher sleeping time in the child thread. So it seems that the main thread finished its execution. So for example, here main thread is executed. Then child thread here to complete some more execution 1, 3, 2, 3, write 1, 2, 2, 2, write 1, 1, 2, 1. Then it has to exit, exiting child thread, exiting child thread, exiting child thread. Here, if you want, here if you try to print the value of name here, it seems that exiting child thread 1, exiting child thread 2, exiting child thread 3. This is one possible way. Another one here, in case if you remove this comment here, new thread of t dot start. Removing this comment, as we done in the previous example, while calling the constructor itself, we are calling the run method. So if the comment t dot start is removed here, you need to remove these 4 lines, thread t1, thread t2, thread t3. because here itself we are creating a thread class object. The thread class object calls the corresponding start method. So comment on these 4 lines and remove the single comment. You can see the same flow of execution. Having any queries in this example?
Sir, could you once again explain the purpose of the statement thread T1 is equal to new thread of in the parameters n1, comma 1?
N1 comma 1. See, to call the run method, right, we cannot call using the thread class object. New thread object cannot invoke the corresponding run method. So what we have to do means the thread class object should be passed as a parameter to the new thread class object should be passed as a parameter to thread class constructor. So n1 is passed as a parameter to this thread class constructor. Then n2 is passed as a parameter to thread class constructor. Then n3 is passed as an object to the third child thread object t3. Then we can call a t1 dot short, t2 dot short, and a t3 dot short. This is a normal procedure. In
What
case
is the purpose of that second argument, sir?
second argument is that simply write the overloaded version of a thread class constructor. Where is it? Okay. In thread class, right, you try to see thread class defines some constructors, overloaded constructors. These are the constructor summary of a thread class thread. Then second argument, thread takes one string argument. The thread is string name. A thread, this one, runnable target comma string name. This version we are applying. New thread of runnable object. The class which implements a runnable interface. That object is passed as a parameter here. That is this one, runnable
Sir, will the
target.
second argument affect the output of the thread class?
Second argument is simply this is passed to the thread class constructor, right? So that here the string value is passed 1, 2, 3. The string value can be processed. If you want, you can extract the value of that string one, because that string is passed as a parameter to this string instance. Just one reference with name to find out right which child thread object is currently entering. In case if you remove these lines, here itself we have provided the string names 1, 2, 3. Thread new thread n1 is equal to new thread of 1. This stage what will happen is the constructor is called. In the constructor, if you want set a name, you can use a t dot set name of name. Then child thread is treated. Here itself we are calling this a flow of execution, calling the run. So consider the 3 child objects n1, n2, n3 are created. These are said to be child threads. When the constructor gets executed, there itself we are initializing the value of name. Name is equal to yes. And the thread's name has been set using set name method. To try to check here, what is set name? Void set name string name. This is a method of thread class. It changes the name of this thread to be equal to the argument name. Name of the thread is set to this specific parameter name. Child thread is printed. I have removed this comment line, the line, right? Comment is removed. T dot start means from the constructor itself, the child thread is going to be started. Run method is going to be called. Likewise, second child object n2 is created and the third child object or thread n3 is created. These 3 child objects are trying to complete each other to complete their run method. File has been saved. File saved. Java C. Okay. And see the flow of execution. So understand the procedure when you implement the runnable interface. Let me show the procedure again. First, what you have to do is you need to implement the class from the runnable interface. That is the first step. Define a class to perform a multi-threading activity while implementing the runnable interface. Second, you need to define the multi-threading activity inside the run method. There you need to define the run as public one because that is the interface method. When it gets redefined, you need to use the public access system. Then define an object of implemented class. Define the object of thread class. That stage, right? Overloaded versions of thread class of that. Here, if you want, you can pass the string message as the second argument of a thread class constructor. First argument, it must be a thread class object. Say thread is equal to new thread of runnable interface object. That is this one. Runnable target. Second version will be runnable target. Then third one, second one string name. If not, only runnable target can be placed. After that, you need to call the run method using the thread class object itself, a t.start. This is the procedure to be followed when implementing the runnable interface. Multi-threading, then this one we have seen. Okay. Then I have some specific examples before moving on to what is synchronization, how Java achieves synchronization with respect to the multi-threading. Let us have one more example. Multi-number.java. I solved a specific example in multi-threading using this problem scenario. Design three different classes to perform multi-threading activities or multi-threaded activities. The three different classes should perform this operation. One, to check if the given number is positive, negative, or zero. So checking if the given integer is positive, negative, or zero. This is one multi-threaded task. Second, checking if the given integer is odd or even. This is another multi-threaded task. Third one, printing the divisors of the given integer. So anyhow, only one integer is required to perform all of these three multi-threaded activities. Suppose integer is n. We can check in once run method if n is positive, negative, or zero. In another class run method, we can check if that n is odd or even. In another class run method, the same integer n is passed so that we can print the divisors of the n. We need to write a main method to create the respective child threads and test these activities for n inputs. That is the problem. Let us try by writing the extending the thread class. Class check number. This is one class, right? So checking the number is positive, negative, or zero. So class check number user defined class extends the thread class. Inside this user defined class, if we need, we can define constructors, and we need additional methods are required. We can define additional methods. But to simulate the multi-threaded activity, the additional methods should be called inside the run method. We defined one integer variable, say int n, since n is going to be processed here. Check number int a, check number. This is a constructor. Your actual parameter is assigned to this formal parameter, which is further used to redefine this instance variable n. N is equal to a. Now we need to check if n is positive, negative, or zero. So we are directly writing the logic inside the run method. If n is equal to 0, we are checking, right? If n is equal to 0, the message n is 0 is printed. Else if n is less than 0, the message n is negative is printed. Else n is positive is printed. This is one class. This class purpose is checking if the value of n is 0, negative or positive. Another task is we need to check if the given integer is odd or even. Since we need to design three different classes, in the second class we need to get the same n and check if n is odd or even. For example, class check odd even. The user defined class should extend the thread class. So extends thread. Inside this one instance variable n is defined. Then check add even, the constructor is defined. The value of actual parameter is used to initialize the variable n is equal to x. The multi-threaded activity is defined inside the run method. Public void run. Checking if n mod 2 is equal to 0, we are printing the message n is even, else the message n is add. Print. Third multi-threaded activity is printing the divisors of the given integer. For example, a class print divisors is designed, which should extend the class thread. The constructor is defined here. The constructor initializes the instance variable n, which is received from the actual parameter. So later inside the main method, we do want to create, we do want to pass the value of n. We can control through a for loop. So using the for loop, you can directly pass the values. The same value of actual parameter or same integer can be passed to the respective constructors. Print divisors, check add even, here check number. The run method here prints or checks the divisors of the given integer n. R j is equal to 1, j less than or equal to n, j plus plus. Using the modulus operator, we are checking if j is divisible by n or n is divisible by j. That is checking if j is a factor of n. If n mod j is equal to 0, we are printing the value of j. Then j is a factor of the given n. So three classes run method, multi-threaded activities are separately defined. Then inside the main method, for example, a main thread is started. Check number COBJ, new check number of 15. Then a second class object is created. We are passed the same parameter. Then a third class object is created. We are passed the same parameter. If not, we can include these three lines inside a for loop, right? For the control variable I ranges from suppose 10 to 100. That I can be directly passed as a parameter to this. So it seems inside the main method, three child objects are created and one main thread starts its execution. 1 plus 3, the 4 threads are starting. Three child threads execution is started here. Object dot start method. And another three more child threads, say C object 1, CH object 1, P object 1 are created. They are also tried to call the corresponding run method. Multi-number 1 minute. Java C multi-number dot Java. Java multi-number. Thread starter. Say 15 is positive, 15 is add. After that, what happened? 198 is positive. So see the flow 15. 15 is checked, right? First positive, then 15 is even. Before printing the divisors of 15, control comes back to the main method. It has started, I think, 198. Next line, 198 is positive. Then divisors of 15. Have a look into this for loop. Divisors of 15, as the message is printed, and before the control goes to execute the for loop, unconditionally, right, the control is transferred to execute to some other process. So after that, you can see divisors of 198, then colon 198 is even, then the divisors are printed here. Divisors are printed, the divisors of 15 and the divisors of 190, 198 are completely printed here. This is a scrambled output. These are of course, the divisors of 15 and 198. Output is completely scrambled. Because after printing some divisors of 15, it may transfer the control to print the divisors of 198. After printing some devices, control rate comes to continue the execution to print the devices of 15. Then it may transfer the control to continue the execution of devices of 198. So it seems that these are the devices of 15 and 198, but the output is completely scrambled. Second run, right? We can try. Third run. Next run. So here you can see that the output is varying from a run to run. Here the program is not to be synchronized. Synchronized in the sense that when one object enters into the critical region, after that, right, what happens when it is released, when it relinquishes its control, another child object is entering into the critical region, so that before the completion of the first child thread object, we are getting some scrambled output. To avoid that, right, what we have to do means Java supports object synchronization. Using object synchronization concept, we need to place which object is going to be synchronized. In that stage, even in multithreading, only one object is allowed to complete the execution of the run method at a time. Even whenever there is some hardware interrupt or when the child thread is expecting some keyboard input values, that stage, assuming that if the object is synchronized, context switch will not transfer the control to execute some other child thread, even when the child thread is synchronized object is expecting some keyboard inputs or having some interrupts. That is the logic of object synchronization. So by revising this code into object synchronization, if you print the devisors means the devisors of say 115 is printed first and the devisors of 198 is printed next, assuming that the child thread objects are completely synchronized. That is the logic of object synchronization. We discuss object
Sir,
synchronization. Yeah.
sir, if we add the sleep time after the start methods, will it first complete everything of 15 and then come to 198, sir?
I could not hear you, please.
Sir, if we add the sleep time after the start methods,
After the start method, okay. After these.
start method for 15, sir.
After which one? This one.
Yeah, that one. POBJ dot start off.
After POBJ dot start here, right?
Yes, sir.
Adding a sleep method. How to add a sleep?
Then will it print all the devices of 15 and then go for 198 executions if sufficient time is given?
Yeah, sufficient time. Say some 2 seconds are given. So that stage, right? Sure, right? There is a probability, right? Positively, right? We expect the devices of 15 will get printed because here main thread is waiting. One important point, many times I have said, the flow of execution is sequential execution. Sequential execution, first line is to be printed first. then next one, next one, next one, right? The three child objects are created. But here the start is called, right? This object is right called, then this object calls the run method, then this object calls run method. In case of multi-threading, here we can't predict right when the context switch releases its control to execute some other child. But after this, right, when the control comes to execute the thread or sleep of 2000, the sure main thread is waiting for 2000 milliseconds. That stage, we cannot find the execution of the subsequent statements. Subsequent statements are simply saying main thread is suspended for 2000 milliseconds. That stage, right? Since already the child threads are started, so it seems that child threads are competing each other to complete their execution. So positively, we can expect the devices of 15, right, will be completed within this reasonable sleeping time. Devices of 15, what happened? Are they printed devices of 15? 15 is add 1 minute. Thread dot sleep of 2000. Where is the devices of 15? Devices of 198. Before that, devices of 15. Devices of 198. Message is showing. Devices of 198. Did we set the sleeping time in the child thread? Okay, try to set 5000. Devices of 15. Printed here, I think 153. Dot sleep. Devices of 15. 15 is positive, 15 is add. Devices of 15 not get printed. But before that, control tried to call this method, I think, COBJ 1 dot start. 198 is even. Devices of 198. That message also printed. Third dot sleep.
Sir,
But can you find out the reason?
Is the program saved, sir?
Program is saved, I think. Oh, we need to check right where is actually saved. 1 minute. I close this file. 1 minute. Packages. Multi-number. Yeah, unexpectedly it has been saved in multi-threading folder. That is the problem. Later, thread dot save. Save value to this. File save. Thread dot sleep, right? It may throw which one? The interrupted exception. So what happens? The method throws checked exception, right? Interrupted exception. The method, the caller of the method must be safeguard against this runtime error. So place interrupted exception. What happened? 15 is positive, right? See the runs, last two runs. 15 is positive, 15 is add. Devices are 15, 1, 3, 5. 15. After that, 198 is positive. Here also 15 is added, divisors of 15. 15, 1, 3, 5, 15. Then 198 is even. 198 is positive. Since we set right enough as the sleeping time here, as the logic of right sequential execution, when the control comes to execute this statement in the sequential order, main is going to sleep for 2000 milliseconds. Sure, that stage the control is transferred to execute the child thread activities. So probably right we can expect the complete execution of the child thread activities because minimal operations are going to be executed in the corresponding child thread activities. So then only you can expect the subsequent execution inside the main mode. Even right there is another method called join method is there. Sure, right, we will explore in the next session. Join method. See inside the main method here, for example, if you call the join method, what will happen means the main thread will be waiting until the child thread execution is completely over. That is the purpose of join method. Join is defined like this. Final void join throws interrupted exception. So if you call the join method, in the next class I explain again, right? Just to have a look into this one. This is of course a different syntax. Thread class object dot that is user defined class object dot then thread class object dot join. So in case if you write ob1 dot d dot join, what will happen means the join method is called inside the main thread. So main thread will be waiting until the execution of the object once run method is over. Then ob2 dot t dot join second thread, right, child object ob2's run method is going to be called. Main thread will be waiting till ob2's run method is over. Likewise, right, you can see the sequential execution, say inside try 1, try 2, try 3 in the sequential order the output is coming because main thread is calling the join method. So when the thread calls the join method, right, the method waits until the thread on which it is called terminates. Which method is waiting? Main thread, right? Main thread is waiting until the thread on which it is called, that is the child thread, until the complete execution of child thread is over. Main thread is waiting. So the logic comes from, right? Calling thread is waiting. Calling thread, who is the caller? Main thread. Main thread is calling the child thread. So until the child thread finishes its execution and it calls to come back to the main thread will be waiting. For that purpose, right, we need to call the join method. We explore in the next session, right? Demo join methods. Okay, thank you very much.
Thank you, sir.